All right. Let's put our names in the chat
Verona.
and
Ahorita para allá, mi amor.
all right. Be sure you're on mute. There's the right classroom.
Yeah.
Where's your finger?
I tried opening nail glue and I failed.
Oh,
Yeah, that stuff is thick plastic.
well, that's, oh, shorts. So they're gone? No, there it is. Boy, this thing is taking a lot of abuse. I hit it with a chainsaw right there,
Mhm.
and I tried to take the tip off of the knife, just the mushrooms. And there's a piece missing there, it's missing there. My mom had a crock pot that had a aluminum thing that went inside, the pot was vented, and I was twisting it to pop it open, and my thumb went across the top and just sliced part of it up.
Ow.
When I was in fourth grade, I was throwing glass in the culvert, and I took out a huge chunk of my skin, my thumb finger.
Wow.
Yeah. I was closing a trap door with this hand,
Mhm.
and I slammed this finger in it.
The only other thing I have is a burn from when I used to work at a bakery.
This right here, very faint.
Mhm.
I think I was in 9, 10 or 11.
Mhm.
My family had gone to Six Flags. It was Six Flags was relatively new. And we rode the log ride.
Oh, yeah.
And I was sitting up front, which is kind of rare for me to be able to sit up front. I have 4 brothers.
Oh, okay.
And so, we came down, I had my hands down below, and we went down, I went like this, and there was something hanging down. I don't think it was a nail, but it was something that hadn't taken care of it. I will let you cut me there. Okay. There's a scar in one of my, either, I think it's in this one. I think it's right there. I was over my bed, and there was something in my bed, and I put my hand out when I was a kid,
Mhm.
and telling them, and I put my hand on it and flipped over, and it just pulled it. You can't tell where. Let's see, we started on my hand.
Mhm.
My wife was paying a ticket at a Justice of the Peace, and I thought she was gone. It was after 10 o'clock, and she had come home.
Mhm.
And so, anyway, I went there to see what was going on. And while I was walking up, there wasn't lights at the place, and it was at a business place, and I tripped over, the sidewalk was all busted up because a tree was thrown up, and I fell on back of my head. All that stuff. Cops and the doctor. But that was, yeah. Man, I've really beaten my hands up over the years. Yeah, that chainsaw one was something else. And during that same event, the chainsaw got away with it from me, and I almost hit my then girlfriend, who is now my wife, with the chainsaw. Yeah, if she was a foot closer, I would have hit her right about here.
Oh,
Yeah, that would have been bad. Yeah, I had a friend in an acquaintance in Friendswood, Texas, which is just south of Houston. We were living there for a while. He was chainsawing and bounced the chainsaw off the back of his hand.
mhm.
And they said he was gonna have messed up all the tendons and everything in there. And he was a biologist, worked for the US government. And they did all the work to fix it up. And turns out, he said he was only getting at best 90% of his hand back.
Mhm.
And he was determined, and he got about 95 or 100%. He got almost basically it totally back. I couldn't tell. So yeah, I'm rattling on about my war injuries. Yeah, I got a bunch of them. Yeah, I used to ride a scooter. This is my first hit the road rash. Scar. Let me see, where were we? Are we into chapter 7 yet? Yeah, we did inverse tangent functions. Did we do them all? Or we did cosine, we did secant, cosecant, and cotangent as well. I don't think so.
We have done on slide 265.
Oh, okay, that is in approximating the value of an inverse trig function. Okay. Okay, I see it. I see it. Letter D. Oh, it helps if I turn that on. And turn the. I need to adjust this. All right. People of Zoom need to pin my screen. That way it's the predominant video in the Zoom. So if anyone else talks, you won't lose my picture. Okay. So my daughter bought this coffee that was has the pumpkin spice stuff in it. And I had a cup of it the other day and it was just, I didn't taste it. But today it's really coming out nice. Okay, I love pumpkin pie. I love so much. I buy the small baking pumpkins and I make. I cook the squash and then I make it from scratch. Except for the crust. My daughter sometimes makes the crust, but she's quit doing that of late. Okay, where am I? Oh, so we want to find out what the cotangent, the inverse cotangent of a -1/2 is. And my question is, okay, so you want to look at where cotangent of theta equals a -1/2. And so what they did was, since this is x over y, right? Cotangent is x over y. That means the x value, and they put the negative sign with the numerator, so they said -1 divided by 2. So they drew a right triangle. So they could find, they know what x is, it's -1. They know what y is, it is 1. I mean, it is 2. And they want to find out what the radius is. And so they just use the Pythagorean theorem. 2 squared plus 1 squared equals this side squared. And so you get 4 plus 1, which is 5, and the square root of 5 is what that is. So that's the square root of 5. So yeah, the angle has to fall between 0 and pi. And so that's why they put it up here. If it had to be between -pi/2 and pi/2, like some of the functions need to, like tangent would need to, then you would, then instead of having -1/2, it'd be 1 divided by -2. So you would move that negative sign instead of to the numerator, you'd move it to the denominator. Because you want it to be in the right quadrant for the particular domain, for the trig function. And then the inverse will be correct. But we want to find out what theta is. Let's see. Okay. Yeah. All right. So inverse code. Oh, okay. Because we do not have, well, we do have, I do have inverse cotangent. No, I don't have inverse, I have inverse tangent. But we know cosine, they're talking about cosine. Cosine is 1 over the square root of 5. Okay. And well, we could have used sine as well, which would have been 2 over the square root of 5. Either way would have been okay. Either using sine of theta equals 2 over the square root of 5, or this. And it's negative. No, yeah. No, sine would be positive. Well, and sine would have to be in these two quadrants. So it would still be negative. But because we're dealing with this quadrant, no, sine would be positive in that case. But and then doing sine inverse of 2 over the square root of 5 is going to be the same as whatever this is, the cosine inverse of negative 1 over the square root of 5. Okay. So cosine, the inverse cosine of a negative 1/2 is the same angle as the cosine and cotangent inverse of negative 1/2 is the same angle as the cosine inverse of a negative 1 over the square root of 5, which is going to be the same as the sine inverse of 2 over the square root of 5.
Is that always gonna be the case? Like it always just kind of is the same as whatever the cosine or sine is for cotangent?
Yeah. Because you want to write it in a trig formula that you can use on your calculator. Because to find the approximate value means you're going to punch it in the calculator, and the calculator only has inverse for sine, cosine, and tangent. So yeah. Well, we could have done this with tangent. Tangent, it would have been 2 over negative 1. Opposite over adjacent. So we could have done tangent inverse of a negative 2. Any one of these three would have given us the same theta. And this is in radians, so that's 2.03 radians. Yeah, they typically round to 2 or 3 decimal places. 2 decimal places is generally enough, is accurate enough. Please round appropriately, because you could lose a point if you don't. And I misplaced my furry eraser, my fuzzy eraser. Any questions here on this? Now, they tend to go to cosine in all of these when they want to do it, or cosine or sine. But we could have used any, since we had the 3 sides of the right triangle, then that theta and notice 2.03 is between 0 and pi, because pi is 3.14. This is between 0 and 3.14. Ah. I like this one. I like puzzles. Okay. So that tangent, so that's x over y again. Right? Tangent equals x over y. So now
And 3/4 is positive, so that means. And for tangent. Theta has be between negative pi/2 and positive pi/2. And since it's positive, that means it's going to be in the first quadrant. Okay, so it's going to be a positive angle. And x is 3 and y is 4. So this is 3 and this is 4. And so here I have the right triangle, and that means this is going to be 5. One of the things I would teach my 8th graders when I taught 8th grade is the basic Pythagorean triplet is 3, 4, 5. 3 squared plus 4 squared equals 5 squared. And then any multiples of these 3 numbers. So 6, 8, 10, 9, 12, 15, those will be Pythagorean triplets as well. Pythagorean triplets are integer numbers that form a right triangle. I think it's 7, 13, and 14. No. 7, 24, and 26 is what I think it is. But it's been so long. Those are fading away. Well, let's see what they do. And so, yeah, so they it's a triangle, and so the radius is 5. And because it's the side opposite, so that, yeah, and so they just went through to create that triangle. Sine of we're taking sine of this angle. Right? That's what we're saying. We're taking sine of the angle that is that we get from inverse tangent. And this is the angle. Well, sine is opposite over hypotenuse. So we don't even need to find that angle. All we need to do is find what sine of that angle is, which is 4/5. Any questions? Any questions? Golly, drawing that triangle really simplifies things, doesn't it? If we were asking for the cosine of this, and cosine is adjacent over hypotenuse, which would have been 3/5. If they wanted cotangent of this, then that's just y x over y, which would have been 3/4.
So we can use that triangle for basically everything.
We did it on the previous one, right?
Yeah, no, I just,
Yeah, so you create that triangle, and then you can see the relationships of the sine and the cosine and the tangent, and how it relates to the question you're asking. They're asking about. It's a puzzle. You find all the pieces, how do they fit together? This is what I love about math. This is what had me hooked in mathematics. Is here we have a puzzle, and here are the pieces of that puzzle, and this is the end result of the puzzle. Once I put all the pieces together appropriately, I get the answer. Any questions on this? Oops, wrong word. No. Geez, I love this. Okay. So now they're asking for the exact value, which means you don't punch it into the calculator. All right, cosine of sine inverse. Sine inverse, all right, so that means the sine of theta equals a -1/3. And this is between negative pi over 2. That's theta. And a positive pi over 2. So sine is negative in the fourth quadrant. So that means the y value is negative, so it goes down to 3 down here and a positive 1 here, and here's that point. And here's the triangle, where this is 1 and this is 3. One squared plus 3 squared is 10. Right? So 1 squared is 1, 3 squared is 9, 1 plus 3 is 10. So this side is the square root of 10. So cosine, and we're talking about this angle right here now. This is our angle theta. Cosine, and that's negative square root of 10. No, but cosine needs to be between 0 and pi, right? So our cosine of theta is still going to be a -3 over the square root of 10. It's going to be up here now. Because now the 3 needs to be negative. I mean, the 1 needs to be negative, and the 3 is positive. Oh, so it's positive 3 over the square root of 10, which is 3 square root of 10 divided by 10. Multiply numerator and denominator by the square root of 10, so you rationalize the denominator. We always rationalize denominators when there's a radical down there. So let's see what they say about this. So yeah, sine has to be between there. And so oh, I'm such a go-go head. I was thinking X and Y like tangent and cotangent. Got myself into trouble. So this is the Y value and this is the radius. So this is 3. Oh, this is a 30, 60, 90 right triangle. No, it isn't. This is 1 and this is 3, so this is 3 squared minus 1 squared, which is 8, and the square root of 8 is what X is. And so now cosine of that angle is going to be adjacent over, so that's going to be 2 squared to 3 over 3. 2 squared to 2 over 3. Again, drawing the triangle correctly. My apologies. So the mistake I made was to say that this was X, Y over X, when it's Y over R. Where R is the radius of the circle. And R is the hypotenuse of our triangle. Now I'm not going to make the same mistake here. So cosine. Yeah, stupid ass program. Yeah, I should preview these things before I show them to catch all these gaps they do. So cosine is in, so this means the cosine of theta equals a negative 1/3. And this is where theta is between 0 and pi. So it's here. All right, this is the x, so it goes back this way. 1. And r is 3. And so, yeah, we get 2 squared to 2 here again, because 3 squared is 9, and 9 minus 1 squared, 9 minus 1 is 8, and the square root of 8 is 2 squared to 2. And so tangent of theta is y over x, and in this case, y is 2 squared to 2, and x is -1. Yeah, x is -1, and so that's what they got. Which is -2 squared to 2. So it's about writing drawing the triangle correctly and figuring out what the sides are. So you can have the basic trig functions, and then you can find the reciprocal functions, which is the reciprocal of the regular sine, cosine, and tangent. And then the inverses are also the reciprocals of cosine inverse and sine inverse and tangent inverse. But anyway, but as soon as we get that, then we can determine those other things we need to find out. So write this as a cosine of cotangent inverse u as an algebraic expression containing u. So this is writing a trigonomic expression as an algebraic expression. Oh, that's what it says up there in the title. Okay. So theta equals cotangent u inverse. Cotangent inverse of u. So cotangent theta equals u, where theta is between pi, negative pi over 2, and pi over 2, and u is any real number. Okay. This means that cosine has to be greater than 0, which means we're dealing with the first quadrant. Okay. So cosine that the expression now equals cosine theta. Please notice what they're doing here. What is sine over sine equal? And what are we always multiplying by? So we're always multiplying by 1, and sine over sine is 1. So we do this. Now, how did that happen? Again, they just rewrote it. They're not showing you how, this is a trig identity problem. How to get from this to there? Well, I rewrite this as the cosine theta divided by sine theta. I just moved this over to here and moved the 1 over to here, so this is sine theta over 1. It's still the same multiply, right? But isn't sine 1 over cosecant? So this is just cosine and cosine over sine. That's cotangent, right? Because sine over cosine is tangent, where cosine over sine is cotangent. So this becomes cotangent theta times 1 over cosecant theta, which gives us this. This is cool. Okay. Oh, I think Mr. Reader, that's. Yes, I am. Proud. Okay. And so, how'd they get this? How'd they get this? Remember the Pythagorean identities? Sine squared theta plus cosine squared theta equals 1. We want to get to cotangent. So that means I need to divide through by sine. And so I get sine squared theta, sine squared theta, sine squared theta. And so sine over sine is 1, or sine squared over sine squared is 1. And then cosine over sine is cotangent, so this is cotangent squared theta. And 1 over sine is cosecant, so this is cosecant squared theta. And this is one of the Pythagorean identities, is simply by dividing this one by sine squared. And if I divided through by cosine squared, I would have gotten tangent squared plus 1 equals secant squared. And then I just take the square root of both sides, which is the square root of 1 plus cotangent squared theta equals the cosecant theta, which is what they did here, which is how they got this down here. Right? Cotangent u. Cotangent theta is u, cotangent theta is u. So that means cotangent squared is u squared. So now I have u over 1 plus u squared. What they did was, now they know that cotangent theta is u, so I want to get only cotangent in this expression. So I can replace cotangent with u. Well, we discovered that cosine of cotangent inverse of u is cosine of some theta. Right, the cosine of whatever this angle is. And they're saying this equals theta. This in here equals theta, so this is going to be cosine of theta, and we determined that cosine has to be, the cosine has to be greater than 0. So we're talking first quadrant. And now we want to write this, so all we have, rewrite this in terms of cotangent. Because we know cotangent is u. And so to get cotangent in there is I divide by sine, but the only way I can divide by sine is by multiplying by sine over sine. Okay, now I want to change this cosecant to something with tangent. So now I have cotangent in here, so this is where u resides. Now I need to rewrite this so it has cotangent in it. Well, we have this trig identity that says, let's see. Okay. That says the relationship between cotangent squared and cosecant squared. But all I need to do is take the square root so I can get what cosecant is. And so, no, I wanted to replace the cosecant with cotangent. And so cosecant is not squared, so I need to take the square root here. And so I have this expression squared, and I know cotangent is u, so cotangent squared is u squared. Again, it's a puzzle, and you take the puzzle apart and you look at the individual pieces and to see how they fit together again. And then we pull in more pieces because that can change it to help me find other pieces to get me to where I need to be so I can put in my final pieces. And it's like a puzzle that you have to beg and borrow from other places so you can change the pieces you have so you can make it go forward. And then find other pieces that you can use, all right? I can use dividing by multiplying by 1. And then I use trig identities to rewrite this product to this fraction. And then I convert the denominator by using the Pythagorean, one of the Pythagorean identities. And we'd be done. All right, trigonometric equations. What's a trigonometric equation? Well, it's an equation involving the trig functions. So solve equations involving single functions, trig functions, solve trig equations using a calculator. You will see that on the test simply because you can use the calculator. It has the functions in there. solve trig equations quadratic in form. So that means you're gonna use substitution, so you get u squared, au squared plus bu plus c that you can factor or use the quadratic formula. Usually you can factor them, I don't. Anyway, and then solve trig equations using fundamental identities, which is what we did here with this one. To find that, we rewrote it as an expression involving u, but that same kind of deal that we did here. And then solve it by graphing. Or a graphing utility. I won't be covering this, although it will probably ask you to do it in the homeworks. I need to go through the homeworks and start throwing stuff out. Because it asks you to do more problems than I require. Okay. Okay, to determine whether theta equals pi over 6 is a solution to this equation. Well, that's easy enough. What's the sign of pi over 6? That's straight off of the unit circle. That's straight off the unit circle. Pi over 6, that's 30 degrees. This coordinate here is the square root of 3 over 2, 1/2. Sine is the y value, which is 1/2. So this is 2 times 1/2. Well, no. The answer here is no. Because you don't get square root of 3 over 2. I mean square root of 3. All right, by replacing in the equation, the result is the sine, and this equals 1/2. 2 times 1/2, and that does not equal 0. So it is not a solution. It's very unusual for them to start out with one that isn't a solution. That's why I was perplexed. And then they want to find out, is pi over 3 a solution? Okay, and so now we're going to replace theta with pi over 3. Well, pi over 3 is over here. That's this angle. Pi over 3, which is 60 degrees. And the coordinates of this point is 1/2 square root of 3 over 2. Right? Is this x and y being reversed? And sine is the square root of 3 over 2. The sine of pi over 3 is the square root of 3 over 2. So now the sine of theta, the sine of square root of 3 over, the sine of pi over 3 is 3 square roots of 2. 3 square roots divided by 2, and we're multiplying that by 2, which gives us the square root of 3, and square root of 3 minus square root of 3 is 0. My calculus 1 professor at UTSA, Mr. Eisenstein, he was getting his doctorate at UT while he was teaching at UTSA, taught me a lot of things. And one of the things he taught me was that pictures never prove, but they help. So knowing your unit circle helps greatly in doing this. I always refer back to it. And then I drew those triangles, and they drew the triangles too. So pi over 3 is a solution to the equation. So solve the equation. Cosine equals square root of 2 over 2. Give a general form for all solutions. List 8 of the solutions. Pretty tall order, huh? So the question is, where is cosine positive? Because square root of 2 over 2, that's positive. So I want to look at where it's positive. Well, that's cosine is positive in the first and second quadrant. So we have here, right? Square root of 2 over 2, square root of 2 over 2. And that's pi over 4. And then over here, which is 3 pi over 4. You get the same cosine. So now we have 2 solutions right away, but we want a general solution that shows up only to these 2 angles. Because I can go around once and then come to here, or I can go around so many times I lost count and end up here. And same thing with 3 pi over 4. So I'm adding 2 pi to pi over 4, k number of times where k is an integer. And 3/4 pi plus the same thing, 2 pi times k. So I can go around the circle k number of times and then still wind up here. This k tells me how many times I go around the circle. K can be negative, okay? So I'm going negative this way, and I wind up here, but I'm adding a positive, so I still wind up back over here, or I wind up here. So it doesn't matter if k is positive or negative, 2 pi means I'm always winding up on 0. And then I'm adding pi over 4 to it, or 3 pi over 4 to it. So that's a general form, and they want you to list 8 of them. And so that's, well, the first, here I have 2, now I just need 6 more. So I multiply by 2, or I multiply by 1, and then that gives me one of these. So that'll be what, 8 pi plus what, so I have pi over 4 and 9 pi over 4, and another 2 pi would be 17 pi over 4, and another 2 pi would be what, 25 pi over 4, and for 3 pi over 4, I add another 8 pi over 4 to it, which is 2 pi, and that gives me what, 8 and 3, 11 pi over 4, and then I get 19 pi over 4, and then I get 27 pi over 4. I could have added negative. So a negative 2 pi over 4. A negative 2 pi, so that'd be a negative 7 pi over 4. Right, negative 7 pi over 4 brings me back to here. Oh, they only looked where sine was positive. I mean, no, they looked at these two angles. I don't know why.
You had said that.
Oh, because cosine is positive. No, cosine's negative over here, right?
Yeah.
That's where I screwed up. Cosine's negative there. Oops, that sine that's positive there. Okay. Yeah. That's a 7, and that's a 15, and that's a 23, and that's a 31. Okay. K is in unit. And then 8 of the solutions. They just dealt with pi over 4. So they went back 1 negative, and then they went to why negative? Oh, negative pi over 4, yeah, because that's the same as 7 pi over 4. And pi over 4 and 7 pi over 4. And 9 pi over 4 and 15 pi over 4 and 17 pi over 4 and 23 pi over 4. Okay. This is quite easy. We have 2 sine theta plus square root of 2 equals 0, or 2 sine theta equals a negative square root of 2, or sine theta equals a negative square root of 2 over 2. So we're looking at from negative pi over 2 less than equal to theta less than equal to pi over 2. Right, so sine is negative in this quadrant. And square root of 2 over 2 is a 45-degree angle. So that means theta has to be a negative pi over 4, or a negative 45 degrees, or 7 pi over 4. Okay. The 7 pi over 4 also brings you over the here. Yeah, first solve for sine theta, which is what I did. Subtract square root of 2 from both sides, and then divide both sides by 2. And then you have the interval from all right. So there are 2 angles for which sine is negative. Okay, yeah, I forgot. Sine's also negative down here. So we're not, our domain is from 0 to pi, 2 pi, okay. I was looking at something else with those. So that's gonna be 5 pi over 4 and 7 pi over 4. Or negative pi over 4 and negative 3 pi over 4. But we almost always write them in positive angles. So. So that's just in that interval. So to talk about all the solutions would be talking about the general answer here, which would be 5 pi over 4 plus 2 pi k, and 7 pi over 4 plus 2 pi k, where k is any integer. But then, here, they're restricting it between 0 and 2 pi, so. I had neglected to notice that. So sine of 2 pi equals negative square root of 3 over equals the square root of 3 over 2. And I'm reading that equal sign as a negative sign because I can't see the top half of that equal sign. So 2 theta, well, I know what 2 theta is. What is 2 theta? The sine is square root of 3 over 2. So where is the ordered pair that has the y value as the square root of 3 over 2? Well, that's over here, where it's 1/2 square root of 3 over 2. And that is pi over 3, 60 degrees. So 2 theta equals pi over 3, or pi, or theta equals pi over 6. Well, and sine equals it in 2 places, since we're dealing with the entire circle, and that's here and here, and this is negative 1/2 square root of 3 over 2, and this is 2 pi over 3. And so 2 theta equals 2 pi over 3, or theta equals 2 pi over 6, which is pi over 3. So theta equals 6 or pi over 3. All right, so they have the 2 angles. Right. 2 pi over 3 and pi over 3, and then they divide them by 2. What are they doing here? It intersects it 4 times. Okay. So there's 4 solutions here. All right, so what I did, I found these angles first and then. Oh, and they're just adding K pi to it. Okay. Yeah, because it'd be plus 2K pi. Or 2 pi K, I would write it as 2 pi K. That's how I was taught to write it. And then you divide that by, you need to divide, all right, so they divided by 2 after they wrote the general form. Okay, so they're doing a couple of examples where K is -1, where K is 0, where K is 1, where K is 2. And so they get those angles. So in the, okay, and they wanted to write all the solutions in from 0 to 2 pi. So 0 to 2 pi. Actually, are these angles down, these 6 angles down here. There's negative pi over -2 pi over 3 is 4 pi over 3. Yeah, okay. And so the 4 solutions are 6 pi over 2, 3 pi over 2, I mean pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. So 2 theta would be could be larger than 2 pi. Theta has to be between 0 and 2 pi. Notice they did not close that interval on this end at 2 pi, because 2 pi is the same as 0. So square root of 3 for tangent, and it's positive. Tangent is positive in the first and third quadrant. Right? Square root of 3. Where is sine the square root of 3 over 2? Well, that's at pi thirds, and it's also at 4 pi thirds. Is where, so that means theta minus the square root of 3 over 3, I mean minus the pi over 3 is going to equal pi over 3, or theta minus pi over 3 is going to equal 4 pi over 3. And then the appropriate multiples. All right, period is pi. So in the period 0 to pi, then the value is pi over. All right, so they're just looking at one angle, and then because the argument. All right, so write it in general form. And so theta minus pi over 3 equals pi over 3 plus k pi, where k is any integer. So that includes all the multiples of the period. The period is pi. Okay, so that's how it includes these two angles. All right, because I was looking at 2 pi. And so, but we only looked at 1 pi. And so for 1 pi, it only hits tangent is only at square root of 3 in one spot. And so, and then if I add pi to that, then it takes me down to here to 4 pi over 3. And then we add pi over 3 to both sides and get 2 pi over 3. Pi over 3 plus pi over 3 is 2 pi over 3 plus 2k. And then are they going to find, okay. So in that interval, there are only two solutions. So 2 pi over 3 and 2 pi over 3 plus pi, which is 5 pi over 3. And there's our solution set. Right? Because well, actually, there should be 2 more. Or 1 more. Okay. All right, so this is going to be just using tangent inverse of -2. All right, so you type in, you use the tangent inverse key, which is on the TI calculators. You hit second and then tangent, and then you type in -2, making sure you type the negative sign and not the minus sign, but you'll get an error otherwise. And make sure you close your parentheses, and then it'll give you a number. And they ask you to round it to 2 decimal places. So this is the second decimal place. With the 7, you round up. And so this is going to be a -1. -1.11. And that's just punching it into the calculator and then rounding to the appropriate place. Okay, so for tangent inverse, the angle has to be between -pi over 2 and 2 pi and pi over 2. But we want, so the solutions, we want to include more than just that intervals. So we want to go down to negative 3 pi over 2 to pi over 2 and well, I go in the positive direction, not the negative directions, but so since the period of tangent is pi, the angle's pi minus a negative 1 point. So this is basically adding that angle, but we're subtracting it. And so we're adding 2 to this angle, and then we're adding 2 pi to this angle, because those two values will end up falling inside that region. And so the angle 3 pi minus 1.11 is outside the interval. So that's why we're not including it. And so we get 2.3 radians, and we get 5.7 radians, 5.7, 5.17. 2 pi is 6.24. And this is less than 6.24. And 2.03 radians is definitely less than that. So those are your solution sets. There's no pi written here. That's why we use radians to talk about it. The pi is included in this multiply. The pi is included in this number. So it's pi times some decimal number, pi times some decimal number. Because if I divide 2.03 by pi in the calculator, I'll get a decimal number less than 1. And here I'll get a decimal number less than 2. And it's probably not a nice fraction. And there are my two solutions. So 2 pi minus 1.11 and pi minus 1.11. So those are those two values, which is the 2 point whatever and the 5.17, I think. Well, to start with, I can take the square root. And so I have 2 sine theta equals 1 equals plus or minus 1. And so sine of theta equals plus or minus 2. Oh, they factored it to 2 sine theta minus 1 and 2 sine theta plus 1. Yeah. Here I have the difference of 2 squares. So the square root, the sum of the square roots times the difference of the square roots. And set each one of those equal to 0. And so you get sine is either a negative 1/2 or a positive 1/2. And sine is negative 1/2 in 2 places, from 0 to 2 pi, and sine is positive 1/2 in 2 places. So that gives us a lot of solutions. Yeah. A pi over 6 and 5 pi over 6 gives us positive 1/2, and 7 pi over 6 and 11 pi over 6 give us a negative 1/2. And so it's gonna be those, the general, and we're just looking in that interval from 0 to 2 pi. If we wanted to write all the solutions, then it would be these 4 fractions plus 2 pi k, or 2k pi. That's what we write it as, 2k pi. Okay. Which one was? I'm curious to see how they do this one. I would take the square root of both sides. Square root of 3 cosine theta equals sine theta. And cosine and sine have the same sign in the first. In this quadrant. And this quadrant. But since you're squaring it, then we have all 4 quadrants represented here. So when is sine the square root of 3 times cosine? Well, that's when cosine is 1/2 and sine is the square root of 3 over 2. Actually, I think it's more than that. Okay. So using Pythagoras, we can convert this so we're only using cosines. And the reason we want to only use cosines is because we're doing 3 times cosine here. And if we write everything in terms of sine, then we're complicating things by multiplying by 3. So cosine is 1 minus sine. Or sine is 1 minus cosine squared. So this becomes 1 minus cosine squared. And now I'm going to add cosine to both sides. And now I'm going to get a quadratic formula equation again, because I'm going to add a minus I'm going to add cosine squared to give me 3 cosine squared equals 1. Oh, and then they so sides and got this, and basically you're doing the same thing now. So here's a perfect square, and here's a perfect square. So I'm going to have the sum of the 2 square roots times the difference of the 2 square roots. So the square root of 4 cosine squared theta is 2 cosine theta. The square root of 1 is 1. So I'm going to have 2 cosine theta plus 1 and 2 cosine theta minus 1. Setting each of those equal to 0, you get cosine equals 1/2 or negative 1/2. Well, cosine is 1/2 here and here. No, cosine is positive 1/2 in the first quadrant and fourth quadrant, and cosine is negative in the third quadrant and the third quadrant. So at 1/2, it's pi over 6, right? No, it's 3 pi over 2. I mean pi over 3. So we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay. So we have those 4 angles. And since all of those angles are between 0 and 2 pi, those are our solution set. That was cold, cold, cold. All right. We're gonna do something similar. Either write it as cosine in terms of cosine or sine. It just depends upon which one you choose to use. And I'm curious as to which one they're going. I'm gonna cheat a little bit. And so, yeah, they wrote it in terms of cosine. So they're using the same way. Except there's a typo here. This should have been squared. Okay. So this should be squared here. I don't know why. Uh-oh. Whoa. No. That's not right. I'm wondering if they wrote, if this is a typo, if the square is a typo. Because this, if this was squared, then this would be 1 = 3, and that's an impossibility. And so, yeah, so this 2 should not have been there. This is not cosine squared, it just should have been cosine squared. It should have been just cosine. And so now we have it in quadratic form. And so we factor this. Oh, there's no real solution set. Because, yeah, okay. Yeah, because we would have u squared minus u plus 2 equals 0, and the factors of 2 that add to 1 do not exist, that add to a -1 do not exist. Then we would use quadratic formula. And to find out what this is, then that's going to be the -1 squared minus 4 times 1 times 2. And so you get 1 minus 8. And so you're trying to take the square root of -7, which is not a real number. Okay. It's an imaginary number. That's where the name imaginary and real numbers came from, is when they were first trying to decide about square roots of negative numbers. Someone was saying they exist, and the powers that be in mathematics were saying, no, it does not exist. It's not real. It only exists in your mind. It's imaginary. And that's where the name came from. And so, yeah, so this has no solution.
Can you go back to the last slide? So technically the sine plus cosine equals like 1, and it says like that it equals 3. Technically, like we already know that there's not going to be anything. Does that make sense? Or no?
Right here?
No, the top, like the equation, yeah, because that already equals 1, right? Or
Well, yeah, the cosine, sine squared plus cosine squared equals 1, not 3.
yeah.
And so, so that would have been, there would have been numbers out front of cosine and sine
Oh, okay.
for it to equal anything other than 1 here. So that means this was a type.
Oh, it was a type.
Okay. Yeah, so I think I can fix it, but maybe not. Let's find that real quick. That's available, I mean. There it is. That's not. What slide number is this? 294. That took care of it. Okay. I was gonna bug you for a while. And now I have to fix it in the other slide I have over in another classroom. When I get to it in that class. Okay. So yeah, if you have sine squared, cosine squared, plus cosine squared, and it equals anything other than 1, then something's wrong. There's no solution. Because right here, we would have gotten 1 equals 3, which is a false statement, so we have no solution. Okay. So 5 sine of x plus x equals 3. So can be not solved by previous methods. So everything we've done so far, we can't solve this using any method we've had before. The simplest way is by using a graphing utility. And so to do this, we get the sign on one side of the equation. And so that means 5 sine x equals a negative x plus 3 or 3 minus x, because I'm subtracting x from both sides. So I could either write it that way or write it as 3 minus x. And then I divide both sides by 5, and I get the sine of x equals a negative x plus 3 divided by 5. And so this is what I would type into the graphing calculator. Divide by 5. Is I would under y sub 1, I would type in sine of x, and under y sub 2, I would type in my prejudice is to write the x first, but you write it this way, or this way. Either way, you type it in exactly that way, and then you look at the and excuse me. And then you're going to need to adjust the Windows settings to see where it hits. You could do it in Desmos on your computer, or you can use the TI graphing calculator. Either way, it will show you what you're going to be. And so, yeah. Oh, you know what? Yeah, that works just as well too. You just put each side of the equation in as one as a function. So this is where you have 2 functions are equal. And so we're looking at a constant function, y equals 3. So you have a horizontal line running across. It's just how often does it hit this stuff? And 5 sine x plus x, you're basically, it's the sine function, but you're having angular rotation with the sine function. So if we turn this a little bit this way, It's a sine function. It's just been rotated. Oh, man. I took a class in high school called analytical geometry. And that's the sort of crap we were doing. We were rotating sine functions, we were rotating ellipses and hyperbolas. It was fun. I enjoyed that class to no end. And the teacher I had for trigonometry, and everybody hated her, but I loved her because I understood everything she was saying. And it was just all a big puzzle that you needed to put together again. And then the analytical geometry just kind of just went, wow, this is fun. Okay. You're getting to see a little bit of my excitement about mathematics. And so the x coordinates of where they intersect, well, it intersects at 3 locations. Because once you get down here, the sine function is too low to hit this, and so those 3 functions. And so with the TI calculator, there's intersections. So you find this intersection between 0 and whatever this value is, and then between this value and this value, and then between this value and this value, you find those 3 intersections. Or you just put the tracer on y equals 3, and you approximate this value, you approximate this value, and you approximate that value. And you get just over a half, and just under 3 1/3, and just under 5 3/4. So this one's between 0 and 1, this one's between 3 and 4, and this one's between 5 and 6. Well, it's less than 2 pi. Okay. And so that's the solution set, those 3 values. Yeah, they say use the intersect to find those 3 values. And that's in the TI calculator. I don't know how Desmos does it, but Desmos has something similar. I'm used to using the TI calculators. And we won't get into section 7.4 today because we have 2 minutes left. And this is, whoa, we only got 2 objectives here, but I tell you, it's a hell of a lot to do. Okay. So we are done. If y'all have questions, I'm quite open to answering questions or anything else y'all may have to want to discuss with me. Okay. So if you're on Zoom, you may go ahead and leave, and if you're in a classroom, again, you may leave. Make sure you come in before you leave. And people are dropping like flies out of the Zoom. All right, I'm gonna go ahead, yeah. Because Rose already done. All right, y'all take care, and oh, Jocelyn. That's right, I have 2 Jocelyn's this semester. My granddaughter's name is Jocelyn. And I think they spell it the same way you do, Miss Gutierrez.
I have a question.
Yes.
Where can you find like a TI calculator, kind of like, not cheap, like cheaper?
Do you have, what type of smartphone do you
iPhone.
have?
I have it on the, what's it called, on an app, but I don't know if we can use it or not, because, you know, it's a phone. So,
For exams,
yeah,
the TI-30A.
okay,
The bookstore had them.
really?
Yeah. They were like $13. You can get them $2-3 cheaper at Walmart.
Oh, okay. I never checked that. Okay, I got it. Okay,
So it's a TI 30A.
38, got it. Okay.
All right, let me make sure you're hearing what I'm saying.
38, like.
Yeah, not 8.
Yeah.
A lot of people hear it as an 8.
Mhm.
It's not an 8, it's 30A.
A.
So it's a TI. And they have several models of this. The real basic model is all you need.
Mhm.
They have more expensive ones which have some additional bells and whistles that I don't use. That I don't require you to use.
Oh, okay.
It's also something you could probably use if you take a stats class, it'll do some of the fundamental stats in
Yeah, I
there.
have to take that class.
What?
I said, yeah, I have to take that class.
If you're gonna take stats, then I would suggest go ahead and investing the money in a TI 80 something.
Right.
The 83 is cheaper.
Mhm.
And it still does a lot of the things that TI 84 does. It just doesn't have as many bells and whistles, but for what you're gonna use it for, you don't need those major bells and whistles. Again, it's still kind of expensive, but you can sometimes, Amazon has them used. So that's something to think about.
Okay, all
Okay,
right, thank you.
take care.
Mhm.
Can you grab it? Whoever's left, do y'all have any questions? There's 3 of you left, 2 of y'all left. Lauren, Victor? Victor, Lauren, y'all got anything for me? You got anything you want me to talk about or answer or nope? Okay, I'm gonna go ahead and close the class. See y'all later. Bye.